So how do computers fit in with the world around them? What does it take to think like a computer? A computer has no predefined concept of what an object is. Take a car or a house. Computers do not know what they are used for. Your computer will not have a favorite brand of a car or how a neighborhood could make one house more appealing than another. So, how do computers see these things in a manner that aligns with how we see these things? Well, programmers create a very different kind of model, especially for computers. Programmers make these models using data. It's not as strange or scary as it sounds because the data is all the computer needs in order to follow the instructions you give it to carry out its tasks. Here's a model of a house, along with model trees, model vegetation, and model cars, and even a model street. To you and me, it's clear what kind of real-world object each item represents. But to your computer, it's all just pixels. Let's look at how computers can create models of the world using data. If you could not see the picture for the house and the cars, the data in the information boxes alone would still tell you a lot about this scene. In computer programming, each physical thing in the world can be represented as an object. There are two different types of objects here, a house and a car. Programmers might say that there's one instance of the house object and two instances of the car object. Each object can have its own properties, events, and methods, and together they create a working model of that particular object. Both of the cars in this picture share common characteristics. In fact, all cars have a make, a color, an engine, and so on and so forth. You could even determine a car's current speed. Programmers call these characteristics the properties of an object. Each property has a name and a value, and each of these name-value pairs tells you something about each individual instance of the object. One of the properties that the cars have is the make, and you can tell the make of the car without even looking at the car by just simply saying, oh, this is a BMW, oh, this is a VW. The idea of name-value pairs is used in both HTML and CSS. In HTML, an attribute is like a property. Different attributes have different names, and each attribute can have a value. Similarly, in CSS, you can change the color of a heading by creating a rule that gives the color property a specific value, or you can change the typeface it is written in by giving the font family property a specific value. Name-value pairs are used a lot in programming. The house object uses property names and values. It tells you about this particular house, such as the address, the square footage, the number of bedrooms, the number of baths, if there's a swimming pool or not. The car objects both share the same properties, but each one has different values for those particular properties. They tell you the make of the car, the color, what type of fuel the car needs to run, the number of doors that the car has, the miles per gallon that it gets. So you can see by ascertaining the properties of the object, we're able to paint a more descriptive picture of that particular object. We're able to fill in the details. Another way you can think of objects and properties are objects are the nouns and properties are the adjectives that describe that particular noun. In the real world, people interact with objects. These interactions can change the values of the properties in these objects. We refer to these as events. There are common ways in which people interact with each type of object. For example, in a car, a driver will typically use at least two pedals. The car has been designed to respond differently when the driver interacts with each of the different pedals. The accelerator makes the car go faster, and the brake slows the car down. Similarly, programs are designed to do different things when users interact with the computer in different ways. For example, you could click on a contact link on a web page and that could bring up a contact form, and entering text in a search box may automatically trigger the search's functionality. An event is just the computer's way of sticking up its hand to say, hey, this just happened. What do events do? Well, programmers choose which events they respond to. When a specific event happens, that event can be used to trigger a specific section of the code. Scripts often use different events to trigger different types of functionality. So a script will state which events the programmer wants to respond to and what part of the script should be run when each of those events occur. If we consider our example here and consider our car objects, a driver will accelerate and brake throughout any car journey. An accelerate event can trigger code to increase the value of the current speed property, and a brake event can trigger code to decrease it. You will learn about code that responds to the events and changes these properties in the next section of this video. Methods represent things people need to do with objects. They can retrieve or update the values of an object's property. A method typically represents how people or other things interact with an object in the real world. They're like questions and instructions that tell you something about the object, using information stored in its properties, or change the value of one or more of that object's properties. So what does a method do? Well, the code for a method can contain lots of instructions that together represent one task. When you use a method, you do not always need to know how it achieves its task. You just need to know how to ask the questions and how to interpret any answers that it gives you. In our example here, the value of the current speed property needs to go up and down as the driver accelerates and brakes. The code to increase or decrease the value of the current speed property could be written in this method, and the method could be called change speed. So if we bring together everything we've been talking about, computers use data to create models of things in the real world. The events, methods, and properties of an object all relate to each other. Events can trigger methods, and methods can retrieve or update an object's properties. Here, if we refer to our car object, as a driver speeds up, the accelerate event fires, and the accelerator event calls the change speed method, which in turn is going to increase or decrease the value of the current speed property. The value of current speed property is going to reflect how fast the car is actually traveling. So you can see how data can be used to create a model of a car in this example. So just keep in mind that computers create models of the world using data. The models use objects to represent physical things, and objects can have properties that tell us about the object, methods that perform tasks using the properties of that object, and events which are triggered when a user interacts with the computer. Programmers can write code to say, when this event occurs, run that particular code. In this way, we can approach a problem, break it down into these steps, and then come up with a script that will solve our particular problem. As this course progresses, we'll be starting with basic examples and then building upon them and creating more interactive and complex scripts that will allow users to interact with web pages and have it respond in particular ways.